Okay, question number 1. Given the function ax to the 5th power, that's all we need. The power is 5, that's your n. 5 minus 1 is 4. 4 minus 2 is 2. 2 minus 2 is 0. Remember, that's the problem in class. We kept subtracting by 2 till you get to 0 and 1. At most, how many possible x-intercepts exist? Again, this is because of the power 5. There are 5 possible or maximum x-intercepts. Again, because we have ax to the 5th power, if your a is positive, greater than 0, that means positive. What is the left and right hand behavior? Well, again, x to the 5th, we're going to go down to the left, up to the right. If you had just drawn that picture, everything would have been golden. But if my a is less than 0 for the next question, then it flips over the x-axis. So now we go up to the left, down on the right. Question number 2. Given that function, already in factored form, everything is there to graph it. We have 2x is going to be equal to 0, that's one of my factors. X plus 4 is a factor, that's going to be equal to 0. And x minus 3 will set equal to 0, so that means x is going to be a 0 and occurred once. X plus 4 tells me x equals negative 4, but it's going to be 3 times for its multiplicity because of the power of 3. X is going to also equal 3, and because it's squared, that tells me that there's going to be 2 answers. So x to the 1st times x cubed times x squared is x to the 6th. So that tells me my left and right hand behaviors have to go up in both cases because every x is a positive. Now we plot our x-intercepts. Negative 4, 0, and 3, obviously in numerical order. As I come down here to the left, since negative 4 has to occur 3 times, it has to look like a cubic curve right in there. Then we're going to turn and go down. We're going to turn and come back up. Go through 0 once because it only occurred once. We'll go up, turn back down, make a parabola shape where 3 is at the vertex. We head back up, and that's my graph. Number 3. Prove that x minus 2 is or is not a factor of that function. So again, what we want to do is we want to solve this for x. X minus 2 is equal to 2. We're going to run 2 through the synthetic division table, drop down to 3, multiply by 2 is 6, plus 8 is 14, times 2 is 28, plus a negative 11 is 17, times 2 is 34, plus a negative 28 is 6, times 2 is 12, minus 12 is 0. So because your remainder is 0, yes, it is a factor. That was our remainder theorem we had talked about. Another theorem we had that went along with the remainder theorem and factor theorem was we could evaluate f of 4 using synthetic division. So whatever you get for a remainder here, that's what f of 4 would equal. So again, running through the synthetic division table, as you can see, drop down to 2 times 4 is 8, plus 0 is 8. Why the 0? Because there's no x to the 4th term up there, so you have to have a place value for that term 0. 4 times 8 is 32, minus 11 is 21, times 4 is 84, minus 30 is 54. 54 times 4 is 216, minus 100 is 116, times 4 is 44, plus 100, 564 is my remainder. That's the remainder theorem, f of 4 equals 44. The previous problem was the factor theorem. Number 5, list all possible factors of that possible function to solve it. Again, we're taking our factors of our constant, 1, 3, 9, 27, over our factors of our leading coefficient 2, 1 and 2. We build all the possible ratios, 1 over 1, 3 over 1, 9 over 1, 27 over 1, 1 over 2, 3 over 2, 9 over 2, 27 over 2. Make it all plus and minus, and those are your possible choices. Number 6 down below. Before we want to do this, you want to graph it. So I typed it into my calculator. There's my equation all typed in, 2x to the 4th minus 13x to the 3rd power minus x squared plus 57x plus 27. We'll go zoom 6. 1, 2, 3, trace. On the 3rd tick mark, I'm going to test the 3. Yep, it's a 0. Looks like there's something between 0 and negative 1. The only possible choice it could be is that 1/2, so I would try negative 1 divided by 2, and that's a 0. I'm going to try for this one here, between -1 and -2. That'd be -3 over 2, again based off my answers in number 5. Whoops, that's not a 0, so my only possible zeros are going to be 3 and -1/2. So finding those zeros, taking your function to -13, -1, 57, 27, run 3 through it, drop down to 2, times 3 is 6, minus 13 is -7, times 3 is -21, minus 1 is -22, times 3 is -66, plus 57 is -9, times 3 is -27. Yep, we get a 0 at the end, which we should. If you didn't, you made an error. Go back and fix. Now we're going to run 1/2 through the synthetic division with our leftover quotient. Bring down the 2, -1/2 times 2 is -1, minus 7 is -8. -1/2 times -8 is +4, minus 22 is -18, times the -1/2 is a +9 is 0. 2x squared minus 8x minus 18. I notice that everything is divisible by 2, so I divided out the 2 here. There's my new equation. It will not factor, so I opted for completing the square, so I added the 9 over to the other side. To complete the square, we're going to go plus blank on both sides. Half of -4 is -2. Squared is going to be 4. So the x squared and the -2 squared is going to fit into my binomial as x minus 2 being squared. 9 plus 4 is 13. 2 steps away, take the square root of both sides. I will get x minus 2 equals plus or minus the square root of 13. Add the 2 over to the front of the plus or minus. There's two answers, x equals 2 plus or minus the square root of 13. And the ones from the graph, x equals 3 and 1/2. Okay, question number 7, solve the equation in exact values. We're going to use our calculator to find some factors. So I typed in the equation into my calculator to graph it. Again, we hit graph. That's my Zoom 6 window that will appear. And lo and behold, right here, come on cursor, wake up, there you are. Right there at the second tick mark, so trace. 2, enter. 2 is one of my zeros, but because it makes that skinny little parabola there, that means it happened twice. So I go over to my synthetic division table, where you're going to divide out x equals 2 twice. So there's my table. We write down the 1, the 2, the -7, the -28, the 52. We bring down the 1, we multiply by 2. That's 2, plus 2 is 4. 2 times 4 is 8, minus 7 is 1. 2 times 1 is 2, minus 28 is -26, times 2 is -52. Plus 52, that's my 0. We'll run the 2 through again because we had 2 of those answers. Bring down the 1. 2 times 1 is 2, plus 4 is 6. 2 times 2 is 12, plus 1 is 13. 2 times 13 is 26, minus 26 is 0. 1x squared plus 6x plus 13 is equal to 0. Again, we will do completing the square. So it doesn't factor. We're going to subtract over the 13 over to the other side. We are going to take half of a +6, which is +3. I'm going to square that and make it 9. The x squared and the plus 3 squared is going to go into my binomial, x plus 3, all of that squared. -13 plus 9 is equal to -4. We take the square root of both sides. I get plus or minus 2i. I subtract the 3 over, sneak in front of the plus or minus, and there is my other two answers that are complex. X equals -3 plus or minus 2i, and my two 2's. Alright, for the next question, write a 4th degree function. Let's see if I can straighten out my paper here a little bit. We have x equals -3 and a +3 and 1 plus I. So we will take these two conjugate answers, write as x equals plus or minus 3, square both sides, x squared equals 9, subtract over the 9, that gives you x squared minus 9 equals 0. If you wrote out two binomials, x plus 3, x minus 3, you'll get the same thing. My conjugate answers, you have to have a complex conjugate as another answer, so 1 minus I is another possibility. That's my x equals 1 plus or minus I. We subtract over the 1 because we want to get the I by itself. We have a binomial x minus 1. We square both sides. Foiling it out, you get x squared minus 2x plus 1 equals now -1. That's I squared. Add over the 1, x squared minus 2x plus 2. We now multiply those two together. That gives me x to the 4th x squared times negative 2 is negative 2x cubed. X squared times a 2 is plus 2x squared. Negative 9 times x squared is negative 9x squared. Negative 9 times negative 2x is positive 18x. Negative 9 times positive 2 is minus 18. Combine those two middle terms, and there's my final answer, x to the fourth minus 2x cubed minus 7x squared plus x minus 18. Okay, so we have the next equation, x to the fourth minus 4x cubed plus 14x squared minus 16x plus 52. Given that one of the zeros is 2 plus 3i, you're going to have another answer, 2 minus 3i, that's its conjugate. So we're going to have to run this through the synthetic division table. So we set up our synthetic division table, 1, negative 4, 17, negative 16, 52. Remember to space it out because we are going to be putting in a lot of complex numbers. So it's time to run 2 plus 3i through the synthetic division table. So over here to the right you can see I got 2 plus 3i still here as my x. We bring down to 1. We multiply, and that's 2 plus 3x. So we're going to go minus 4. That's negative 2 plus 3i. Multiply that by x. That's going to be my negative 13. Move that up underneath the 17. I'm going to add 4 to that, or excuse me, plus 17. That's my 4. My 4 to be multiplied by x. That's 8 plus 12i up here. Minus 10. Negative 8 plus 12i times x. That's my negative 52. That gives me the 0. So now it's time to run 3 minus 2i. We bring down to 1. 2 minus 3i is 2 minus 3i. Notice everything canceled. That's a 0. Anything times 0 is another 0. Bring down the 4. 2 minus 3i times 4, that's going to give minus 12i, which matches up here perfectly, which gives me 0. So x squared plus 4 equals 0. Subtract over the 4. That's negative 4. X squared equals negative 4. It gives me x equals plus or minus 2i. So there are my 4 answers as soon as I move the camera down. Alright. X squared plus 4 equals 0. X squared equals negative 4. X equals plus or minus 2i. And the other two answers from above. Okay, translate the function f of x equals 1 over x. This is similar to what we did in class. Remember we talked about plotting our points on our graph. So if I had to graph 1 over x plus 3, all that minus 2. Plus 3 is inside the function. That means set equal to 0, solve for x. X equals negative 3. We're going to the left 3. The minus 2 tells me I'm going down 2. So the first thing I want to plot are my basic points. So in red, those are my basic points. Remember, if we put 1, that'd be 1 over 1 put in a 2. X is 1/2 gives me a y of 2. X of 1/3 gives me the reciprocal 3. And you get the same picture over here in the red dots down below. So what we had to do is we knew that our x and y axis was our horizontal and vertical asymptotes. Therefore those had to move first. So technically what I did first is I just moved the asymptotes. Basically taking my x and y axis and moving it 3 to the left and down 2. Drew in those green dotted lines as my asymptotes and then replotted my points. And again, I was really concerned that you hit these points. If you didn't, I marked something about it. You can't miss those. They're too easy. Alright? Don't touch the asymptote lines and everything's good. Number 11. Given that function x minus 3 over x squared minus 1, the vertical asymptotes, take the bottom, set it equal to 0, solve for x. That means we're going to add 1 over, x squared equals 1, take the square root of both sides, x equals plus or minus 1. It is a vertical line, so it has to be x equals. The horizontal asymptote, notice that the top power is x to the first, the bottom power is x squared. That means this is case 1. Our horizontal asymptote is y equals 0. To find our x-intercept, you set the top x minus 3 equal to 0, solve for x. Yes, x is equal to 3, but you have to write it as a point, which is 3, 0. Alright, our y-intercept is that ratio of our constants up here. Negative 3 over negative 1, that's going to be a 3, so my y-intercept is at 0, 3. Now for the graph, taking all my data, let's, oops, lost my focus there. Let's graph our horizontal asymptote in red, that's y equals 0, our two vertical lines, our vertical asymptotes in green. Remember, we put open circles there. We put in our x-intercept at 3, 0. We put in our y-intercept at 0, 3. Because it was a positive x on the top and a positive x squared on the bottom, a positive divided by a positive is a positive. So the region furthest to the right is positive. Between that x-intercept and that open circle is negative. Between the two open circles it's positive, and after that open circle it's negative. So here's my y-intercept. I'm going to get a little parabola shape up at the top. I cannot cross the x-axis between those vertical asymptotes because there's no x-intercept. At this x-intercept, I got to go down to the negative region. Remember in class we said we got to kind of go up, make a little bit of a speed hump, and come back down. Some of us hit this point and stayed below the horizontal asymptote. No, that means you're still in the negative region. You got to go above it. And over here, this is all negative, so we'll draw that curve, just like a rational function curve, over here, approaching both the horizontal and vertical asymptote. Find the equation of the slant asymptote or oblique asymptote. Well, the bottom power is smaller than the top, so we got to divide this into the top. Thank goodness that's a linear equation. We can do synthetic division. So 1, -2, -3. We're going to take our x minus 1, solve it for x. X is 1. Run that through the synthetic division table, but remember there's no remainder here, so just cross off the last column. Drop down to 1 times 1 is 1, minus 2 is -1. Your slant asymptote equation is y equals 1x minus 1. Okay, our next rational function, we need to factor that. Alright, so you had to do the factoring here. It wasn't as easy as the last one to solve those vertical asymptotes. So the top factor is to x plus 3, x minus 2. The bottom factor is to x minus 2, x plus 1. Oops, looky there, we got two that are the same. That means you have a hole. We cancel those out. That hole is going to occur at x equals 2. We'll find the y coordinate when we get down later on in the question. My vertical asymptote is the x plus 1 left over on the bottom. That's x equals -1. My horizontal asymptote, well, because it's x squared over x squared, it's going to be 1 over 1. That's my leading coefficient ratio. Y equals 1. That's case 2. X-intercept, looking at what's left over on the top, x plus 3. Solve it for x. That's -3, 0. Solving for the y-intercept, looking at the 3 over the 1, that's the only thing that's left, or the -6 over the -2 will also tell you that that's a 3. So there's my -3, 0, there's my 0, 3. Now, how to find the rest of the whole? We know what happens at x equals 2. Take what's left over. The x3, put in the 2. On the bottom, the x plus 1, put in the 2 for x. 2 plus 3 is 5. 2 plus 1 is 3. 5/3 is my y coordinate. 2, 5, 2, and 5/3 is my whole. Alright, now it's time to graph our function. So, whoops, knocking stuff over here. So we have our horizontal asymptote at y equals 1. We have our vertical asymptote at x equals -1. We have our x-intercept at -3, 0. We have our y-intercept at 0, 3. You also have that hole at 2 and 5/3 right there. Open circle right there. Alright, so we draw in through our x-intercept. We're going to go below the horizontal asymptote and going below here. Over here, we're going to draw a normal curve through the y-intercept, through our hole down here. Again, remember, on the right side of that vertical asymptote, it's positive because it was an x squared divided by x squared. Between that vertical asymptote and that x-intercept, we're negative. After the x-intercept, we're back to positive. Number 14, now I give you all the information looking for you to make the perfect graph. So we have a vertical asymptote at x equals 2. There it is, that green line. We have a vertical asymptote at x equals -1. That's my other green line. You have a horizontal asymptote at y equals 2. That's my red dashed line. You have intercepts at 1, 0 with a multiplicity of 2. That means it has to look like the parabola there. At 0, -1 is my y-intercept. Again, based on my graph, where my points are, we're going to make a parabola shaped down here. Now, because these two green vertical asymptote lines only occurred once, since I went down on the left, I got to be up here on the right. And I got to stay above that horizontal asymptote. I'm down on the right side of this vertical asymptote. I need to be up here on the left. Remember, we talked about those alternating. The only time they don't alternate is if there was a multiplicity of 2. 14b, we wanted to write a rational function for part A. Okay, so My two vertical asymptotes on the bottom gives me these two binomials, x minus 2, x plus 1. On the top we had the multiplicity of 1 for the x-intercept, that's x minus 1 squared. Now here's where a lot of people goofed. If you notice that our horizontal asymptote was at y equals 2, that means you had to have a ratio in the front, 2 over 1. So we had to multiply by that extra 2 in the front, right here. If you didn't, you would have noticed that for your y-intercept, if you went to put the 2, you would have had negative 1 squared. Negative 2 times 1, that would give you a negative 1/2. That's not what my y-intercept was. My y-intercept was at 0, negative 1. So we had to multiply by that 2 to get us to negative 1. 15. We have an inequality. What signs am I looking for? That starts right here. Less than or equal to 0. That tells me I want negatives. What are my x-intercepts? These are points. You have to write them as points. The top factored. Factor by grouping, x squared times x plus 3 minus 4 times x plus 3. The x plus 3 comes out. The x squared minus 4 factors to x plus 2, x minus 2. So my intercepts are plus or minus 2 comma 0 and a negative 3, 0 based on my binomials. What is the sign of the right-hand behavior? Again, because it's x cubed, it's going to be positive. So let's make our number line. Plot your 3 points in numerical order. Negative 3, negative 2, and 2. Alright, positive, negative, negative. Again, we wanted the negative region, so we shade the negatives. Our circles are closed because it was an equal to line. Look back above, there's my equal to line. My interval notation, negative infinity to negative 3 bracket, union bracket, negative 2 to 2 bracket. Okay, question number 16. One of two ways to do this. You know me, I don't like negatives in front of my x to the 4th, so I divided everything by a negative, so that changes it to x to the 4th minus 10x squared plus 9 is less than or equal to 0, so that switches it around. So now I factor it. We talked about any time that first power is twice as big as the second power, you can factor it just like you normally do. Except we'll get x squareds in front. So two factors of a positive 9 that add up to negative 10 is minus 9 minus 1. X squared minus 9 I know gives me x equals plus or minus 3. X squared minus 1 gives me plus or minus 1. Now we go write that over here on my number line in numerical order. Negative 3, negative 1, 1, 3. Now that my x to the 4th was positive, my right-hand behavior is positive. Then we alternate from there. My circles are all closed, again because of the equal to line. But now that I change it to less than or equal to 0, I want negative regions. So I shade the negatives. That's bracket negative 3 to negative 1 bracket, union bracket 1 to 3. If you would have left it alone, factored out a negative 1, left it over here, then got your negative 3 and positive 3, negative 1, positive 1, still with the negative over there would have been greater than, your right-hand behavior would have been negative, then positive, negative, positive, negative, and we still would have shaded the same regions. Number 17, here's our rational. We have to factor the top. X plus 5, x minus 2. That gives me x equals negative 5 and 2. Those will be closed circles for my x-intercepts. On the bottom, these are vertical asymptotes, or open circles, plus or minus 4. So we plot our numbers, negative 5, negative 4, 2, 4. Make the 4 and negative 4 open. The other two are closed. We have a positive x squared divided by a positive x squared. That's going to be a positive right-hand region. Alternate from there. We want greater than or equal to 0, which means we want those 3 positive regions to be shaded. So negative infinity, comma, negative 5 bracket, union with parentheses, negative 4, comma 2 bracket, union with parentheses 4, comma infinity. Number 18, the problem here, which a lot of us overlooked, is the fact that it's not set equal to 0. So you have to subtract over the 1, and then you have to multiply the top and the bottom by that denominator. So that would give me negative 3x minus 6, because I need to multiply that again, that denominator, by a negative 1. That gives me common denominators, combine like terms. I now have negative x, negative 2x, couldn't read my paper here through my viewfinder, negative 2x minus 8 over 3x plus 6 greater than or equal to 0. I did a little factoring, took out a -2 on the top, a 3 on the bottom, so that gives me x equals -4 on the top, x equals -2 on the bottom, plotted those points. Since -4 was on the top, it's a closed circle, -2 is on the bottom, it's an open. Since it has a -x, -2x, that's going to be a right-hand behavior that's negative. Then it's going to be positive, then a negative. So shade the positive because that's what I want. My answer is bracket -4, -2 parentheses. If you did the extra credit real quick, again, if you would have done the synthetic division, testing the 4, because it's positive, the rule said the whole bottom row has to be positive numbers. My last 3 numbers are negatives, so it's a no, and the reason had to match, not all positive values on the bottom. For -4, now because that's a negative or a lower bound test, now when you run -4 through the synthetic division, your bottom row has to have alternating signs. Since I'm going positive, negative, positive, negative, positive, yes, it is a lower bound because my signs are alternating along the bottom. That's the end. Thank you.